turning EVs into mobile batteries. The multi-billion-dollar potential of V2G technology. As the world shifts toward renewable energy, a new challenge has emerged: intermittency. Because solar and wind power depend on the weather, the electricity supply fluctuates constantly. However, a growing movement in energy technology suggests that the solution to stabilizing the grid might already be sitting in our driveways. A recent pilot project in Delaware, led by Willett Kempton at the University of Delaware, has demonstrated that vehicle-to-grid (V2G) technology could allow electric vehicle (EV) owners to earn thousands of dollars annually by acting as a distributed battery network for the power grid. The concept, cars as giant collective batteries, the logic behind V2G is simple. Most EVs are parked and plugged in about 95% of the time. Instead of letting that potential sit idle, V2G allows the grid to draw power from parked cars during peak demand, such as early mornings or evenings, and recharge them when supply is high, such as midday when solar production peaks. The economic and environmental benefits are significant. Cost efficiency. Kempton notes that using EVs for storage could cost roughly 1/10 of the price of building dedicated, massive battery farms. Renewable integration. By smoothing out the peaks and valleys of energy production, V2G makes it much easier for countries to rely on volatile renewable sources like wind and solar. Profit for owners. In the Delaware study, 4 Ford EVs retrofitted with V2G technology showed that owners could have earned as much as $3,359 per year by selling electricity back to the market. The technical hurdle. The format war, despite being conceptualized as early as 1997, V2G has struggled to reach the mass market due to technical complexities. The primary issue lies in the conversion of electricity. Power grids run on alternating current (AC), while EV batteries store energy as direct current (DC). To feed power back to the grid, that energy must be converted from DC back to AC safely. Currently, the industry is divided into two competing technological approaches, reminiscent of the 1980s VHS versus Betamax battle. DC V2G, the Betamax approach. This involves using expensive external wall chargers to handle the conversion. While highly efficient, the high cost of these chargers has slowed adoption. Companies like Volkswagen and Nissan have explored this route. AC V2G, the VHS approach. This involves building the conversion technology directly into the car itself. While potentially slightly less efficient, it could be much cheaper to implement, adding only a few $100s to the vehicle's cost. Major players like Tesla, BYD, and Renault are moving in this direction. To really scale and get to mass market, you've got to align on one standard, says Alex Skok of Octopus Energy. The infrastructure challenge. A double-edged sword. While V2G offers a way to stabilize the grid, it also creates a new problem: increased strain. As millions of EVs begin communicating with and drawing from the grid, the existing electrical infrastructure will face unprecedented pressure. Experts warn that V2G is not a silver bullet that can be implemented overnight without preparation. Recent research from the National University of Singapore suggests that countries should avoid piecemeal upgrades. It is more cost-effective to upgrade power grids holistically now to prepare for the massive influx of electrical demand that V2G will inevitably create. Conclusion: V2G technology represents a massive opportunity to turn EVs from passive consumers into active contributors to a green energy economy. However, for this revolution to succeed, the industry must resolve the battle over technical standards, and governments must invest in modernized grid infrastructure to handle the new flow of energy.